Hi guys, welcome to this session on P4 radioactivity. This one is about irradiation and dose. So we're going to look at today, we're going to look at these two words, irradiation and contamination. A lot of people get confused between what is what. We're going to look at dosage, what that means, and different doses that you may get from different sources. We're going to be looking at how you reduce contamination and irradiation, and then analyze some data on dosage as well. So these two words, contamination and irradiation, people do get mixed up with these. Irradiation is the easiest one. Irradiation means that you expose something to radiation. Typically when they talk about this, they talk about a person being exposed to radiation. Now that can be a good thing, because sometimes we might want to expose someone to radiation if we want to treat cancerous tissue. So if you have a tumour, we want to expose the tumour to X-rays or to gamma rays in order to destroy that tissue. That can also be a bad thing, because if you're just exposing someone to radiation and it's not for something like a tumour, then it can ionize healthy tissue and therefore then lead to cancer. So that's why radiation can be useful, can also be very harmful as well. Contamination is where you have something radioactive either in or on you or on a surface. The most dangerous part being on a person or in a person. The example I give to someone is saying, like, imagine you've got a biscuit. Now, if you eat a biscuit, if you have a biscuit on your hand, you leave crumbs on your hand. Now, those crumbs are like if you held or in contact with something radioactive. When you have removed it from yourself, you will still have atoms on you. Even though you might be able to see them, you'll still have atoms on you that will be decaying. Now, the problem then comes is because these atoms are going to be decaying, they're going to be giving out radiation. Therefore, your body is going to be exposed to radiation, which then can lead to ionizing cells, damaging healthy cells and making them cancerous. So you can say that contamination could lead to irradiation, if you like. So yeah, just a reminder for ionizing radiation, the reason why it does damage healthy tissue is because the ionizing radiation, in this case alpha, will go into atoms and they will remove electrons from those atoms. Those atoms will be the ones making of DNA. If you start changing that DNA, then leads to mutations. So these here are some different methods that we can use to reduce things like contamination and irradiation. So one on the top left here, this one here is a lead apron. So usually used in medicine, but people wear a lead apron, very heavy apron, in order to reduce the effects of irradiation. Definitely going to stop things like alpha and beta, but also reduce gamma as well. If you look at this apron, it's only covering the major organs. That's why it's not covering things like the lower legs and the arms. This person here, and the second picture, if you like. So in the second picture, this person is at the dentist and at the hospital. At the dentist, you can have these as well. They use lead there. So this person's wearing lead over their lap. They use lead in order to reduce the irradiation on healthy tissue. So this person's having an X-ray of their hand. They do not want organs anywhere in their body. Basically, they just want their hand being exposed to the radiation, in this case X-rays. In particular, when they do this, when they shield you from the radiation, they will shield things like organs that are more susceptible. So it might be the reproductive organs, things like the heart and the stomach as well, that are replicating at a high rate. You could have the old hazmat suit here in number 3, if you like. The hazmat suit will just reduce contamination, but you do not want that radioactive source on you. You could say it reduces alpha radiation being absorbed by the body, and maybe beta, but it's mainly to prevent contamination. Fourth one, these are forceps. So forceps, massive tweezers, if you like, they're to reduce contamination. So you're not in contact with a radioactive source. So whenever you see a teacher handling something radioactive, they will usually use the forceps to make sure they are not in contact. They've also got gloves on as well in order to reduce that contact. You could say that maybe for something like alpha radiation, where it has a range in air of a couple of centimeters, it also reduces the irradiation due to alpha. This picture here is just saying things like, if you want to reduce the amount of radiation that you absorb from a source, then you just reduce the amount of time you have. Reduce the amount of time you have around that radioactive source. The sixth one here, the sixth one is basically, these are the containers that they use to store radioactive sources in. So they're normally lead lined and they're in a wooden box. So we need to make sure that radioactive equipment is stored safely and securely, to make sure that no one can get hold of it, because you never know, some people might not know what this sort of stuff is and might not understand about radioactivity and the dangers of it. So we want to protect people. When we're finished with radioactive waste, what we also do is we like to seal it in things like lead or concrete or a ceramic, and then we will bury it or have it in a secure location to make sure that the public don't get near it, and also to reduce things like contamination to things like water supply or the environment. So we don't want anything from this radioactive material getting into the environment. This one sort of relates, number 8, the eighth one, sort of relates to the 4 steps, keeping your distance. I mean, if you're reducing your distance, definitely you're going to reduce contamination, but you're also going to reduce irradiation as well. So if you're getting further away from an alpha or beta source, definitely you reduce the amount of radiation you absorb. And this is something they do when they're using radioactive X-rays in a hospital. The person taking the X-rays, or a dentist, the person taking the X-rays will stand behind a screen. That is to reduce the amount of radiation they absorb, because they are taking X-rays. They're going to be doing this quite often every day, so they want to get out of the way and they want to be shielded from this. So we've looked at those two. Now we're going to look at dose. So when we talk about dose, dose is usually rated per year. It's the average amount of radiation that you can absorb from these different things. So some of them are quite typical, so things like an X-ray or maybe a heart scan, a lung scan are using X-rays themselves. You think got the more obvious one like a nuclear power station. Then we've got transatlantic flight. So if you're flying, you're higher up in the atmosphere, you're exposed to more radiation coming from the sun in terms of cosmic rays. So you will absorb more radiation there than you will at sea level. So we've got things like the magnetic sphere around the Earth, the magnetic field of the Earth protecting us from that. If you're higher up, you're more susceptible for it. Some foods are quite radioactive, things like Brazil nuts. Brazil nuts, I think, have selenium in it, which is slightly radioactive. And then we've got the average radiation dose, sort of background radiation. So just because where we live, we also are exposed to things that give out radiation. So rocks is the main one. In your house, you have things like radon that you're exposed to, the radon gas that comes out of the rocks in the ground. Depending on where you live as well, you may have things like if you're near a nuclear power station, or if you're in an area where we do nuclear testing, probably not in this country, but in others, it can affect your background radiation. What they normally do is they might give you this table and they may talk about these and may say compare them, or may say what can you do in a year. Normally you get a rating per year of this is the average dose that we would recommend to a person. I think it depends, it's about 50 millisieverts, I think. So yes, this unit of this is called a sievert here, and a sievert is quite a large amount of a dose. So whenever we talk about the amount of dose that you get, it's in millisieverts. Now just remember, milli means 1 times 10 to the minus 3, which is 1,000th. So in the exam, you do not need to remember sievert, SV, but you just need to remember the fact that it's in millisieverts. So it may be that you have to convert something. So it might be like, I don't know, if we look at a lung scan, it says that a lung scan is 0.1 millisieverts. In sieverts themselves, that would be 0.1 times 10 to the minus 3 sieverts, or 1 times 10 to the minus 4. It may be something like that you have to convert. So you don't need to remember that unit, but you do need to remember the fact that milli means times 10 to the minus 3, 1,000th, and you may need to do so with this data. As I said, it might be talking about how many things you can do in a year. Has this person gone over their recommended dose of radiation in the year? Things like that. Okay, so enjoy and see you next time.